Welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to think about pedagogy, teaching and learning, professional development, anything of interest to time poor but enthusiasm-rich primary teachers. This week, I'm joined by Christopher Such.
Hello again.
And together, we're going to, Chris is going to field some unseen maths-based questions to me because perhaps not unkindly, but I feel I've thrown some questions your way that you haven't had advanced sight of, so I thought it would be only fair to turn the tables. But first, Chris, what you reading for?
Hey, what you reading for?
This week I came across a paper. It's a discussion piece by Balin et al. From 1999, so not particularly recent. Which is part of the reason why I love it, actually. It's called Common Misconceptions of Critical Thinking. And the thing that I love about it is that from a totally different angle, it explores all of the underpinning ideas that I see in the discussion around comprehension skills. In effect, it's a discussion about the epistemology behind the idea of kind of transferable thinking skills, however they may be applied. There's a brief mention of reading in there, but actually you can take that paper, remove the words critical thinking or critical thinking skills and translate in comprehension skills and end up with an equally coherent, equally enlightening discussion of the subject. Really highly recommended. It's a really invigorating read for anyone who's been thinking about this subject for a while. And just it's pretty brief as well. I think it's only like 7 or 8 pages long, but really, really well written as well. Highly recommended. It's one of these ones that I know I won't be able to resist the temptation to go back and read it again in the next couple of weeks. Partly because it agrees with my biases, admittedly, but also, as I say, because it is just such a cracking read. What about you, Kieran? What are you reading for?
Well, it would have been a while ago now. We had Adam and Sue on the podcast to talk about the Green Paper and sort of where we go with regards to SEND in England. And in March, there was an update. I think the policy paper is called SEND and Alternative Provision Improvement Plan. 101 pages. So I think we might need to get Adam and Sue back in to talk about it relatively soon, but I just thought it worth flagging because it's an interesting sort of next step in what I hope will be a journey, regardless of which political parties are responsible for education. So well worth the read, if not in small, manageable chunks.
Yeah, and I mean, even if you don't have the time to read the whole thing, as with all of the papers of this kind, there's a really solid executive summary. At the moment, that's all I've had the time to engage with. And yeah, you can get to grips with it that way. So yeah, if you haven't got time, always a nice shortcut.
So this week, Chris, you're in charge, assistant to the co-host.
Yeah, I've been looking forward to this for a while. I mean, I was tempted to come up with the most devilish questions I possibly could, but instead, what I did was look back to some of the early days on Twitter when people were still interested in what I had to say about subjects other than reading, or at least I kidded myself that people were interested in that. And I looked back to a lot of discussions that I had there, and I thought, obviously, there were times when I was asking for advice. There were times where there were just conversations that I jumped in on where other people were discussing ideas. And I allowed that to help me generate some questions. Some of them are stolen, like I say, just from the top of a thread. Some of them are questions that appeared further down, but they're all authentic or based on authentic problems that teachers had in the past, mostly from Twitter, a couple from other conversations. So the first of these is as follows. I have a year 4 class with real difficulties with number bonds. They're counting on fingers at the moment, quite a lot. which seems to be slowing them down. They're mostly accurate, but it seems to be holding them back. What would you advise?
So the potential issue here is that these pupils are roughly 8 or 9 years old. And so although the use of digits to count might be on some level an appropriate tool, you would imagine that the mathematics we'd hope that an 8-year-old or 9-year-old would engage with would be a few steps removed from that reality. Really, what you need are pupils who are confident with number, certainly all the key bonds, but even perhaps most of the multiplication tables, because the mathematics you hope they're going to learn will involve the manipulation of both additive and multiplicative reasoning. Have I interpreted the question?
Yeah, in effect, I mean, I remember parts of the conversation, the person in question started talking about how much it was making them struggle with written addition and written subtraction. And also mental arithmetic using, I think they were starting to look into decimals involving tenths as well. So they were doing things like 0.9 and 0.5. And because they were struggling with 9 and 5, then converting that into 9/10 and 5/10 was a bit of a challenge. So they were still kind of seemed to be hampered. At least this was in teacher's interpretation of it, hampered by this. Is it something that they can tackle? Is it something that they should tackle? And if so, how?
Yeah. So, I mean, if they don't understand, or if they can't recall with a reasonable amount of flexibility, the material that you need to build sort of later mathematical understanding with, there's not really much point in exploring fractions. We talk about the right mathematics for the pupils. We talk about not racing through the curriculum. I'm struggling to think of much that doesn't depend on those core building blocks being in place. So I would almost prioritize curriculum time for those things until those pupils, because I can't imagine it's all the pupils. You'd be hard pressed to find that, certainly in a mainstream setting, and even in the special school that I worked in, there was still a range of mathematical ability. The compounding factors or the complex needs weren't always necessarily academic. So, I find it very hard pressed to find a class of 30. Something has gone seriously wrong, I think, if a whole class have come through potentially 5 years of schooling and are completely unaware. So I would make it a priority. You look at things in terms of, is it the Pareto principle? 80-20, and I reckon that 20% of maths has a big impact on the other 80%. Now, that's probably me misinterpreting what the Pareto principle means, but essentially, it's things like, once you've edited the first 20% of your book, the next 60% isn't actually going to make that much of a difference to the quality of the book. So I think that 20% of maths makes much more of a difference than the next 60% of maths. Hopefully no one writes in and says, well, I think you've misunderstood what he's talking about there. So it needs to be a priority. You need to dedicate your time. No point in doing anything else, because if the kids are failing in the absence of that knowledge, well, then they're just going to reinforce the idea that they can't do maths, that maths is something to be endured rather than enjoyed. So prioritize that. So I think it's about talking to your leadership team, talking about your expectations. Perhaps, they're going to ask you, probably rightly so, to demonstrate that things are as extreme as they are, because that's reasonably extreme, that those pupils have not developed an understanding or a automatic recall by that point.
I think it depends how we interpret the question, because if it's, everyone in the class, that's obviously extreme. But if, say, it's half the class are still, getting 9+7 or 8+6 correct, but it's not through recall, it's through putting 8 in their head, counting on 6, then if that's like just a significant chunk of the class rather than all, I reckon that's still pretty common, personally.
Well, that's fair enough. I mean, in that situation, what you could do then is introduce ways of thinking for the pupils that allow them to be smarter with the numbers they're manipulating. So, like, what do you say, 7+6?
I think I said 9+7 and 8+6.
So 9+7. Well, rather than counting on, which is a legitimate strategy, why not just make 10 and then add the rest? And so, if perhaps they haven't introduced that idea, so it could be just mapping out ways in which we can think about number that, seem more complex, but actually alleviate a lot of the burden for us. So, depending on how you interpret the question is right, there are different strategies. If it's a real paucity of understanding, well, then you need to reshape what you're teaching until you have bridged that gap, because then everything else gets unlocked when you can be flexible number. But if it's the case where, well, they're just not helping themselves because they're relying on a count all method, which is essentially what we're, counting on and count all, there's very little between the two. We need to get out the, what do you call it, teaching children to calculate mentally, and identify which pieces of that will help pupils engage with the mathematics. But I mean, if they can't engage with fractions because they can't count, it does feel like there's something serious going on.
Yeah, makes sense. I like what you say there about the idea of it being conditional, because it's tempting just to say do this, but actually if it's this, do this, and if it's that, do that, are generally the most the kind of answers that you get from people who really know their stuff in most situations. I think that makes a lot of sense. I like what you say about in effect different calculation strategies, the idea of introducing them to the idea of converting a calculation to an easier one. So can you make this into a make 10? Can you relate this to a double that we learn? If you don't know your doubles, we'll embed those first. So really solid advice there. Thank you. Ready for the next one?
Born ready.
So I organized these questions. I moved these around a little bit because the order that I originally wrote them down in didn't have kind of what I would consider to be foundational mathematics questions together, but this one now does. This one's a little bit niche. This was from a year 6 teacher who said that they basically had a class of kids who were pretty solid with their multiplication tables. They'd done flashcards stuff to help with that. But before that, they'd done all of the conceptual understanding alongside that recall stuff. But the previous teachers had effectively only taken them up to 10 times 10. They hadn't gone beyond that. Kids were okay with 11s up to like 9 times 11 because of the pattern. But with 12s, it all kind of, there was nothing like the same level of recall. And the year 6 teacher wanted to know, given that this is post the point at which pupils will take the multiplication check, so there's no accountability measures to worry about, is this something they should dedicate some time to? Should they dedicate time to supporting kids to have relatively rapid recall of, the 11 times multiplication and division facts and the 12 times table multiplication and division facts? Or should they just skip that and say, I'm happy for them to treat 12 in the same way that they might treat 13 or 16? In other words, just work out those by applying what they know. Is it worth kind of learning to recall the 11s and 12s and the related division facts as well? Or is it fine just to continue kind of working them out from what's known?
I mean, how many facts is it? You'd imagine you don't need to learn 11 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe 11 times 11, 11 times 12. So that's 2. You don't need to learn 12 times 1, maybe 12 times 2.
Yeah, so you'd want to, because they'd only gone to 10 times 10, presumably everything from 12 times 2, 12 times 3, 12 times 4, 12 times 5, all the way up to 12 times 12 is fair game at this point. It's not one they've got so in a way that they can just recall it automatically.
Cool. Well, I mean, what's that, roughly 12 facts that you need to learn?
Yeah, so 12, 13-ish facts, yeah.
Yeah, so, I mean, that's not going to take a long time if you use flashcards. I mean, we've talked about flashcards in the past. If you get it right, put it in the right. If you get it wrong, put it in the left. And then the next day, come back to the ones initially at the start, that you didn't get correct the first time around. And hopefully that pile gets smaller as you go through. So I don't see why you wouldn't. I'm a big fan of knowing square numbers up until maybe 15 ish. Just because you don't know what type of mathematics you're going to encounter later on, and you don't know what the numbers will generate. I think as a teacher, unless you're being really careful with every single question you ask, and sometimes you should be, you might set a problem that pupils are then ill-equipped to solve, not because they haven't had the opportunity, but because they're focusing too much attention on the number facts as opposed to the underlying mathematics. So I'm thinking, I've got circles in my head for some reason. Thinking at the end of year 6, when you're starting to look at pi and you're starting to look at the radius and diameter and things like that, and it might be a situation where one of those facts comes in useful, and it's just a little bit more attention. You can absolutely get by just knowing up to 10 times 10, but I'm a big advocate for the more facts you have at your disposal, the better. Because I certainly recommend that year 6 pupils are able to work with multiples of 25 as rapidly as possible, because it makes perfect sense, and one of the big blockers for them, maybe even 12 and a half, because again, quite a common sort of phenomenon in mathematics is working with eights and things like that there. And, and you might go even further. Now, a lot of this stuff, in SATs, the question writers have a very specific set of numbers they can use in certain situations, like when they want to encourage long division, they'll choose a prime number. Am I right? It's been a long time since I spoke to anybody about this, but I think they will choose they'll choose prime number divisors to because then you cannot be as flexible with your knowledge of the laws of arithmetic. Yeah, so that makes sense. You can't turn 36 into 12 times 3. From that point of view, there's nothing we can do that will guide them through SATs, because the margins are so small on which questions will feature those tables. But because it's 12, 13 facts, I don't see why you wouldn't.
I guess where I take this question then, I really appreciate, and I agree with this idea of going further with your flexibility with mental arithmetic and what bits and pieces you might be willing to commit to some extent to memory. Like, I think 25s are particularly valuable. 50s, you get to the point where you think, well, there's no point with that, because that really is, your 5s. You can then just apply that by then multiplying whatever answer you have by 10. Can't really do that with 25s unless for some unknown reason your 2.5 times table. So knowing, for example, that 4 25s are 100 and being able to apply that is a really valuable bit of information. I guess the question would be then, on the assumption, or not on the assumption, let's imagine that SATs didn't exist, and so there was no kind of question writing going on there. Would you agree that there isn't the same value to, say, learning your multiplied by 12 facts as there are to your other ones? And that being the case, once you've made the decision to memorize your facts up to 12 times 12, both multiplication and division, would you advocate going further? Because presumably, say, the 15 times table is as likely to be as valuable or as useful as 12 times. Does that make sense? Would you advocate doing that if you've got, say, a year 6 class, they're happy with everything up to 12 times 12, You've also talked about 25. Would you still be thinking, I'm always looking to expand that array of number facts that can be recalled automatically? Or is there a point where you just almost draw the line, not because they're not useful anymore, but just because you want to commit your time and energy to other stuff?
Yeah, I mean, it wasn't my intention to suggest that SATs are the driving force behind anything we do. It's more a case of this is something that preoccupies year six teachers.
Oh yeah, no. To be fair, you didn't. It wasn't that at all. I mean, and as a year six teacher listening to this, I would be absolutely on board with an understanding that you're not saying that that's the driving motivation behind anything, but it's also just a consideration. So yeah, no, I don't think you gave that impression at all.
I think I would. 15s as you were talking, 15 coming as well. Yeah, because obviously you got the length of time, and whenever I'm calculating durations of time, I will typically work in 15s. So, for instance, your empty number line that you use to calculate the duration and stuff, which has a practical application in the real world, might be better served because obviously you can have kids who use a blank number line to count in steps of 1 or 5 and take a long time. So the more flexible you can be with that kind of stuff, and because obviously the blank number line as written eventually becomes your mental number line, doesn't it? So I would look at the mathematics they're likely to encounter throughout, certainly the first 3 or 4 years of secondary school, and then identify, well, how can I give them a leg up? Because they're going to be getting the opportunity to experience increasingly complex situations, quite often in larger groups than they're used to, because obviously you've got your 2 form, 3 form entry primary school, and everyone gets quite a lot of attention because the adults on hand have the capacity to. But if if you're in a secondary school with maybe 8 forms, and not my secondary school had 8 forms, I don't think you're going to get the same attention. I mean, that's not a criticism of secondary teachers. I just don't think logistically you can keep a handle. I mean, Sylvie would be the best person to ask. I mean, eventually we have to get on the podcast, but she'll know whether or not it is actually possible to give, So yeah, I would try and give the kids as much of a leg up as possible, because the more you know, the more you can think, and that's a good place to be. But perhaps not at the expense of other things that are perhaps more important in the moment. But this doesn't have to be hours and hours of time every day. It's 2 or 3 minutes a day to do flashcards, isn't it?
This one's a little more niche, I think, but I liked it. I liked the discussion that came from it, which is in my class, after teaching these things, I find that kids mix up multiples and factors. And that's something that happens year after year. What am I doing wrong?
I mean, it's very hard without being in that person's class, isn't it? Is it a rite of passage? Was it your class?
Well, I think it's everyone's class, if I'm honest. So I guess a rephrase of the question then, to allow more of an expert answer, might be, what might I be doing wrong? And what might I do differently?
I mean, it feels as if you have an answer, so I'm looking forward to hearing what you said to this person. But I mean, yeah, like you say, it could be everybody's class because it feels like a rite of passage. You get a lot of new vocabulary. Lower key stage 2, you're learning quite a lot at quite a rapid pace. I mean, it's year 3 and 4 are definitely up there in terms of, if you're establishing the very fundamentals of reception in 1, you're almost doing the same, but with key stage 2 material, place value, for instance, you're getting a lot on board. Multiplicative reasoning comes in, and in the national curriculum in England, the field axiom is getting introduced along with some other massive mathematical truths. So I think, yeah, I would just keep using the correct terminology, but it might be that the models you've chosen don't necessarily highlight the distinguishing features. So I'm thinking of arrays, and I'm thinking of how you label arrays and how you build arrays and the order in which you build arrays, and you talk about what you're doing as you're modeling, so that when pupils are building their own arrays and when they're sort of exploring 2-dimensional shape, they get a sense of the proportions. I want to say proportions, but it's not the measurements either. But it's like the distinguishing features, isn't it? I mean, the actual word escapes me at the moment. But yeah, but I think so. I'm thinking about, okay, just like with fractions, and I have a preference for saying the number of parts before the sort of the numeration of the parts. So, if we're talking about 3/4, I prefer to talk about, well, there are 4 parts in total. 3 of them are, being used in some way. So 3 of the 4 parts, and would write the fraction in that way, which is not fairly typical because it would normally be a 3 and then a line, then a 4. And I think the same might be true with things like this, where you've got that sense of space, and it might be that the pupil's spatial awareness is just a little bit off kilter. So I don't know. What did you say, Chris?
Well, one of the reasons I bring it up is because at the time I gave what I don't think was particularly great advice, which was, I don't think it's terrible, but I've tried it myself, and I don't think it's the panacea that other people do, which is to, when you come to teach factors and multiples, separate it out a bit. We tend to teach them side by side, factors one day, multiples the other. I think it helps a little to separate them out, but actually I've come round since then to the position that it comes down to what you were saying about usage. It's a case of saying, okay, when we're talking about our multiplication facts, when you're introducing your, 2 times table, well, why not say, okay, so let's count through the multiples of 2. You are using it in practice. I think one of the key things about vocabulary generally is that we forget that kids learn and use vocabulary, and quite complicated vocabulary, accurately all the time if they are required to actually use it for a worthwhile purpose. And I think we can do the same thing with multiples and factors in maths teaching. In some ways, I want that, when they're writing that learning objective in their book, if that's, what you still do, if they're still writing that LO in their book and it's LO, I know what a factor is, or I know what a multiple is, and that's coming in, say, I don't know, year 4, or perhaps a little bit earlier than that, I want them to have been using the word multiple and factor over and over before then, just as part of learning other bits and pieces. So yeah, getting them to actually use the words in practice, finding excuses to use multiple and factor is the key thing. Maybe there's some value in separating out the teaching of factors and multiples when you kind of go back to it, but I don't think that's the panacea that I've seen it described as.
I don't know. I mean, there's definitely a school of thought. I mean, people talk about area and perimeter as well. People can fall out of that, where the kids get them muddled because they've both come within a very short space of time from each other. So there's no reason why we can't separate things that got out in our curricula. So
yeah, I think again, it's fine. I don't think it's a bad idea to separate stuff out. I mean, I put together a curriculum where I intentionally did that. I say put together a curriculum, organized a curriculum from a product that already exists, but I separated certain things out. Area and perimeter were ones, multiple and factor were another. But again, I think it comes back to usage, and it doesn't have to be in mathematics. It can be, you're teaching a science lesson and you're talking about evolution, and you've done a little inquiry where you've spread bits of wool out across the field. I'm only remembering that now because it was in a blog that Sarah Cottingham wrote recently, and we talked about an example for that. But one of the things you do in that situation is say, well, I've got loads of wool spread out across the area of the field. You find excuses to get pupils using any vocabulary that might otherwise be tricky for them to learn. And that's one of the joys of teaching experience. You learn those words that are often tricky because they end up being difficult to differentiate from something else, and you learn to get kids using those in practice. And I think there's possibly an argument relating to embodying this stuff as well. So thinking about perimeter, I got kids all the time when we're talking about perimeter to kind of be making some kind of shape with their fingers. Like, so when we're talking about the perimeter, and it wasn't always a rectangle, it could be a triangle or a circle, but they were always kind of sketching the outline of a 2-dimensional shape whenever we were saying the word perimeter. So that helped. So perimeter and area, it just, these little things that help pupils pick up this stuff, I think can be useful as well. But the main thing is usage. Find a way to get kids usefully using this stuff, ideally across the curriculum. That's the answer I wish I'd given. I didn't. I only talked about curriculum separation. Now, this is a tough one, so there might be a bit of a pause, but here goes. Someone basically said that they were, they'd been asked to be the mathematics lead at their school. They'd said yes. They were looking forward to the job, but it wasn't something they'd ever been hugely confident in teaching. It was more about the fact that they were considered pretty capable, pretty experienced. They weren't a bad maths teacher, but it wasn't something they considered a strength. And they didn't word the question quite like this, but this is how I'm going to word it to make it more difficult for you. If you had to pick one bit of advice for someone in this situation, what would it be?
I mean, there are never pauses because I'm the master editor. So I'll always make it seem as if I'm smarter than everybody else in the room. But so they're becoming maths lead, but they're not 100% keen because there's not their strength. So, I mean, it's the one piece that makes it really difficult because there's a really, I don't know, it's a flippant part of me that thinks that job satisfaction is a massive part of why we teach. You know, obviously helping children is massive too, but there are many, many ways to do that don't involve education. So part of me thinks, well, if you're really not going to be happy in that role, you should either refuse it or perhaps find another role. Because I know that satisfied teachers who feel challenged, who feel respected, and who feel valued, typically will perform to a higher standard than those who do not. You know, simply because those who do not, and I've been that teacher, will just go, well, what's the point? You know, I'm not going to bust a gut and go the extra mile. If I don't give that flippant or answer, then I think fake it until you make it is my advice. You know, because it's not difficult to get a grip on the pedagogy and the subject knowledge involved in mathematics subject leadership. The difficult bit will be reconciled with yourself as to whether or not you're going to get the job satisfaction that you deserve. So I don't know if I answered the question properly, and I'm sure the version you've heard, Chris, will be slightly different from the version that the listeners at home hear. But I think really, you know, any subject needs passion somewhere. And quite often that comes from the subject leader. So if you can't fake that passion, because I know loads, I mean, I think I mentioned this on Aidan Sever's podcast. How I know loads of maths teachers who hated maths, hated teaching maths, but actually became some of the best math subject leaders that I know. So it's not impossible. It's just a question you've got to ask yourself, really.
No, I think it's a really good answer. Yeah, and I like the idea as well of if you're questioning your own sense of whether you want to do this, then a real thing you need to do is to see if you can find out whether, you can fake it. Can you begin to fall in love with the subject or the pedagogy of the subject enough that you can be that support that teachers need? So no, I think that's a really insightful answer.
I mean, people will be having to lead subjects that they're not passionate about. So I'm not insisting that everyone in the country, or even suggesting that everyone in the country quit their jobs because of the the subject they get. But with something as high pressured as mathematics, and with the accountability processes being quite well connected to it, I think it's worth consideration because there's a lot of extra stuff that you might not experience outside of a deep dive.
Quite a pithy question, this one. This is not one from Twitter. It's a question that I imagine most maths leads have faced at some point. I'm not convinced by the value of bar models. What am I missing?
I mean, we both know someone who is very likely to have said that. Like most things, I think bar models come in for flack because of how they can be hoisted um, up as this catch-all solution to the mathematical ills that exist within our education system. And so it'll be a case, these magic bars that can solve all your problems. All you need to do is learn how to use them. And that's not the case, And I've certainly seen bars used in situations where bars perhaps don't need to be used or probably shouldn't have been used. But I do think they have value as a tool for expressing mathematical relationships. And so when used properly and when used sparingly, to really highlight the sort of core properties in a given situation, where their use is applicable, then I think they can be quite illuminating. But where we as teachers are only one step ahead of the pupils, you're not likely to get as much from them. So it requires a proper investment of professional development time from senior leaders, and give their teachers the opportunity to really get to grips with them and the reasons why we might use them. And so, if I think about, there's a trust I've been working with, and I think we've been looking at just Cuisinart rods for perhaps 15 hours this year. Just one resource, just one, and sort of looking at the use across school. That kind of investment, I think, is necessary to become really proficient, because then you as a teacher will know when the right time to use this is and when the right time has passed. So, if someone adopts that position, it's going to be very difficult to change their mind. But it's probably the same as anything. When things get held up, we build them up to knock them back down, don't we? And they can irk people because they're thinking, oh, we've been doing something similar to that, but just not. And there's a lot of political baggage that comes along with it too. But I think like anything, maybe worth exploring why they're used and then making a decision based on that information.
Yeah, I think one of the reasons why they might be derided to some extent in some quarters is the contrived problems that are sometimes created that have obviously been created in order to use bar models. And you think, and often these are problems where you think these are so complicated that anyone solving these would already be familiar with algebra, which is in effect, can be thought of as an extension of bar models, or at least certainly connected to the idea of bar models. Just from a personal point of view, I know it's a while ago now that I found myself initially unconvinced by the bar model, probably nearly a decade now. But the thing that worked for me was finding a particular use for them and then letting it grow from there. So finding one thing that I thought, actually, this does illuminate this quite efficiently, and this does seem to support pupils to understand something that they didn't before. And then after that, there's this temptation to start thinking, oh, hang on a minute, does this apply elsewhere? And so if in doubt, I think finding that one thing, for me, it was fractions and percentages. In particular, finding not just, what's, 3/4 of 120. It was the reverse problem version of that. So 3/4 of question mark is 160. What is the whole number? It's like, oh, okay, that is a whole different business. And it's because that's something that's genuinely really a really useful visualization of that is the bar model. And it can serve as a stepping stone to a kind of an abstract understanding of that stuff that might not otherwise be there. So for me, it was finding one thing and then working from there. Whether that's useful to this person, I don't know. So one final question. I've got a few more, but I'm just going to stick with one more. Someone says that in mathematics, they've got a class that has a pretty wide range of current attainment, and they've been told that they should totally avoid differentiating, I should say, by task. Is that sensible advice? Or do you think that it isn't?
To an extent. I mean, when I started teaching, you would have children who are working at P levels, and you would have children who are working at level 5 in the same class, and on everything in between. So regularly, I would have had to plan and resource 6 lessons or 6 activities for each maths lesson, and that probably extended across most curricular subjects. And I can see why the no differentiation thing sort of came in. The national curriculum identified that we're trying to get all pupils to go in the same direction. But it's almost like an overcorrection, because if a pupil understands something, and I am convinced they understand something, and over practicing things is of value. So it might be that they have to do a little bit more practice before I'm completely convinced that actually they've got a handle on this. There's nothing to say I can't give them a really rich, challenging task, which is completely different from what other pupils have been given, while I focus on the children who need my instruction the most, because ultimately they're the priority. The children who don't understand and perhaps have experienced a legacy of not understanding, they need your attention with the utmost urgency. Pupils who already seem to, the 50% who come into your class already know what they're supposed to, well, let's make things richer for them. And the example I was given, the example I gave at a conference in Brentwood the other day was the idea of French decimal time. And there's a problem on the Enrich website. And essentially it explains the context, and it shows 2 different time, or the same time in both. What do we call our time? Time. And in French decimal time. And I would say to the pupils, typically they were year 5, but it does vary. Right, you've got a week. I want you to be able to explain to me how French decimal time works. And I want you to do a presentation on Friday, And it's not necessarily discovery learning, because they've been given enough information and enough stimuli and enough resources to go to find the information. What they need to do is they need to work as a group to analyze the information they've got and then develop some sort of explanation. And so you are exploring the concept of time and the construct of time, but in a different base. Just like we talk about, instead of giving bigger numbers, work at base 2. So I think there's room for different tasks in the classroom, but it wouldn't be my first port of call. I try to take everyone on the same journey. If people understand something and they're listening to me explain something and I'm going through the nuances and worked examples, well, there's still a chance they might pick up something. So I'm not advocating that I teach 2 different lessons in the same class, but to think carefully about what the purpose of the tasks you set are, and then from there you can decide whether or not an alternative is necessary. Because when it comes to challenging pupils, I always think we've got 3 options. You can be prepared, like preparation. You can have what you've deemed as challenging activities ready to go in your back pocket. So, okay, here's a rich task for these guys. I need to focus my attention over here. You can improvise, decide whether or not you want to go further in the curriculum or if you want to go deeper. And that really depends on your knowledge of the curriculum and the pupils and what the responses they give you. And then you've got generalize, where you generalize, and you set up a problem like the sum of 3 consecutive numbers is the one I always give, where you can move towards mathematical proof within, and that will take months. Well, I don't know about months, but if I set that child up a problem and said, right, I want an actual primary appropriate mathematical proof, it could take weeks. And that's good use of time. Maybe not all of the maths lesson all the time, but it's a problem because you need to test all the different sets. You start with single-digit numbers, two-digit numbers, a range of three-digit numbers, until you get to the point where you think you've got a non-proof argument. So there's a lot of work involved in mathematical proof. So it's a long way of saying, I think there's a place, but we need to be very particular about the reasons we're doing things, just like we do with anything.
Yeah, love that. I think minimize but don't rule out entirely is a pretty sensible way to think about differentiation by task for pupils in maths classes and any class, actually. Yeah, I'd love to ask some more, but I figure it might be worth saving some for what I hope will be a next time.
Fantastic. Yeah, I mean, hopefully those answers are useful. Genuinely didn't see any of the questions in advance, but I've enjoyed it, and I'm looking forward to listening back. All I said to do is say thank you very much. Thank you for joining me, Chris.
Thank you.
And everyone at home, until next time, thanks for listening.